Hello dear students. In this session, we shall discuss some organic nine reactions. Aldol condensation. In aldol condensation, aldehydes or ketones having alpha hydrogen is converted to alpha beta unsaturated aldehyde or ketone in presence of dilute sodium hydroxide. Aldehydes or ketones having alpha hydrogen in presence of dilute NaOH is converted to alpha beta unsaturated aldehyde or a ketone. For example, acetaldehyde CH3 CHO. So CHO you have to write like this, C double bond O H. Okay, CH3 CHO. And here it undergoes condensation. So two molecules of acetaldehyde is needed here for the condensation reaction. So here when you write the next CH3CHO, the alpha carbon atom, this is the alpha carbon. Okay, that one you have to write like this. That CH3 you have to write like this, CH2H, then CHO. And here which is the alpha hydrogen? Alpha hydrogen is the hydrogen in alpha carbon. So this is the alpha carbon. Okay, this is the functional group. The carbon nearer to the functional, adjacent to the functional group is the alpha carbon. So this is the alpha carbon. Okay, here this is the alpha carbon. And the hydrogen present in alpha carbon is called alpha hydrogen. So here in presence of dilute NaOH, this hydrogen atom is transferred here and forms an aldol. Okay, and the formula of aldol is CH3, then C, this one becomes O and H. Okay, so OH, then this is CH, single bond. And here this hydrogen is already transferred. So the rest is CH2, CHO. Okay, this is the aldol formed. Okay, this is called aldol. And when this aldol is heated, on heating, it loses water molecule from here hydrogen, and from here OH is eliminated as water, H2O, and the product will be CH3 CH double bond CH, this becomes double bond CH. This is the alpha beta unsaturated aldehyde or a ketone, and the name of this compound is butyl-2-enal. Okay, this is butyl-2-enal. So acetaldehyde or ethanol on aldol condensation gives butyl-2-enal as the final product. Okay, so aldehydes or ketones having alpha hydrogen undergoes condensation in the presence of dilute alkali to form alpha beta unsaturated aldehyde or a ketone, and this reaction is called aldol condensation reaction. Note that formaldehyde and benzaldehyde do not give this reaction. Formaldehyde and benzaldehyde do not give this reaction. Why? Because no alpha hydrogen is present in formaldehyde or benzaldehyde. Okay, in benzaldehyde, see the structure of benzaldehyde. This is benzaldehyde. Okay, so here this is the alpha carbon. So in alpha carbon, no hydrogen is present. Here also no alpha carbon is present. So no alpha hydrogen is present. So these two compounds do not give this reaction. Cannizzaro reaction. In Cannizzaro reaction, aldehydes having no alpha hydrogen, they disproportionates in presence of concentrated alkali to form alcohol and carboxylic acid salt. Aldehydes having no alpha hydrogen disproportionates. What do you mean by disproportionation reaction? That is, it undergoes oxidation and reduction simultaneously. So aldehydes undergoes oxidation and aldehydes undergoes reduction in presence of concentrated NaOH or KOH to form alcohol. Aldehydes on reduction gives alcohol and on oxidation gives sodium or potassium salt of carboxylic acid. This reaction is called a Cannizzaro reaction. Okay, for example, formaldehyde. Aldehydes without alpha hydrogen, example is a formaldehyde, HCHO. Formaldehyde disproportionates, so 2 moles, one undergo oxidation and another undergo reduction. So here 2 molecules are needed, so HCHO. Okay, 2 molecules of a formaldehyde in presence of concentrated NaOH or KOH. So here you can use concentrated NaOH. Then 1 molecule of HCHO undergoes reduction. Formaldehyde is reduced to methanol, CH3OH, and the another molecule undergoes oxidation. So formaldehyde is oxidized to formic acid. Okay, and here the reaction is taking place in the presence of NaOH, sodium hydroxide. So sodium formate is obtained. Okay, HCOONA. Okay, methanol and sodium formate is obtained. Similarly, benzaldehyde, C6H5CHO. This is another aldehyde containing no alpha hydrogen. Okay, so here also 2 molecules of benzaldehyde on treating with in presence of concentrated NaOH or KOH. Here you can take KOH. Then 1 mole undergoes reduction. So benzaldehyde is reduced to benzyl alcohol, C6H5CH2OH. Okay, and plus this undergoes oxidation. This is oxidized to benzoic acid, and as it is in presence of KOH, potassium benzoate is formed, or potassium salt of benzoic acid is formed, C6H5COOK in place of HK. Okay, so this reaction is called a Cannizzaro reaction, and note that this formaldehyde and benzaldehyde, they do not have alpha hydrogen, so they undergo Cannizzaro reaction. Other aldehydes, acetaldehyde, propanol, etc., do not give Cannizzaro reaction. So these two they do not undergo aldol condensation reaction, but they give Cannizzaro reaction. Okay. Carbyl amine reaction. In carbyl amine reaction, a primary amine is converted to an isocyanate, which is called carbyl amine, in the presence of chloroform and alcoholic potassium hydroxide. A primary amine, aromatic or aliphatic primary amine, on heating with the chloroform in presence of alcoholic potassium hydroxide, isocyanate, that is the carbyl amine having an offensive smell, is formed. Okay, carbyl amine having an offensive smell. It is formed when a primary amine is heated with the chloroform and alcoholic potassium hydroxide. For example, an aliphatic primary amine, methyl amine, CH3NH2, on treating with the chloroform, CHCl3, and potassium hydroxide, an alcoholic solution of potassium hydroxide, alcoholic KOH. This gives isocyanate, CH3NC. Okay, CH3NC is formed. Isocyanate, this is called carbyl amine. Okay, plus potassium chloride plus water. Okay, 3 KOH, 3 KCl and 3 H2O. This is called a carbyl amine reaction. An aromatic primary amine, say example aniline. Aniline on treating with the chloroform, CHCl3, and potassium hydroxide, alcoholic. This gives NH2 group is converted to, here the NH2 group is converted to NC. Okay, isocyanide plus KCl plus H2O plus 3 KCl plus 3 H2O. This reaction is called a carbylamine reaction. Next is Kolb's reaction. In Kolb's reaction, phenol is converted to salicylic acid when it reacts with the carbon dioxide in presence of aqueous alkali followed by hydrolysis. Here, phenol is converted to salicylic acid when phenol reacts with the carbon dioxide in presence of aqueous alkali, sodium hydroxide or potassium hydroxide, followed by acid hydrolysis. Okay, followed by hydrolysis. So for here you can write phenol, the formula of phenol, C6H5OH. Phenol, first it reacts with the sodium hydroxide and forms a sodium phenoxide. Then sodium phenoxide reacts with the carbon dioxide to form an intermediate compound, and the intermediate compound on acidification or hydrolysis produces salicylic acid. And the formula of salicylic acid here, salicylic acid, the acid group carboxylic acid group is attached to the ortho position. Okay, COOH. So when phenol is treated with the carbon dioxide in presence of aqueous alkali followed by hydrolysis produces salicylic acid. This reaction is called the Kolb's reaction. Reimer-Tiemann reaction. In Reimer-Tiemann reaction, phenol reacts with the chloroform in the presence of aqueous alkali followed by hydrolysis gives salicylaldehyde. Phenol on treating with the chloroform in presence of aqueous alkali. First one, reaction with the chloroform in presence of aqueous alkali followed by hydrolysis produces salicylaldehyde. First, phenol reacts with the sodium hydroxide to form sodium phenoxide. Sodium phenoxide then reacts with the chloroform to form an intermediate compound which on hydrolysis produces salicylaldehyde. So the reaction, you can write the reaction like this. Phenol on treating with the chloroform in presence of sodium hydroxide followed by hydrolysis gives salicylaldehyde. Salicylaldehyde in ortho position CHO group. So this is salicylaldehyde. Okay, Reimer-Tiemann reaction and Kolb's reaction. In Kolb's reaction, phenol is converted to salicylic acid on treating with the carbon dioxide, sodium hydroxide and further acidification. Okay, further acid hydrolysis. And in Reimer-Tiemann reaction, phenol is treated with the chloroform in presence of aqueous alkali followed by hydrolysis produces salicylaldehyde. HBZ reaction, Hell-Olhard-Zielinski reaction. In this reaction, an aliphatic carboxylic acid containing alpha hydrogen is converted to alpha halo acids when it is treated with chlorine or bromine in presence of red phosphorus. Carboxylic acid having alpha hydrogen is chlorinated or brominated in presence of red phosphorus gives alpha halocarboxylic acid. This reaction is called HBZ reaction, Hell-Olhard-Zielinski reaction. Okay, for example, acetic acid CH3COOH. Okay, so carboxylic acid is an example of carboxylic acid having alpha hydrogen. This is the alpha carbon. Okay, so alpha hydrogen is present here, and this on chlorination or bromination in presence of red phosphorus gives alpha halocarboxylic acid. See here in alpha carbon, one of the hydrogen is replaced by halogen. If it is chlorinated, it gives CH2ClCOOH. Or if it is brominated, it gives BrCH2COOH. Okay, hydrogen of alpha carbon or alpha hydrogen is replaced by the halogen when it is treated with the red phosphorus in the presence of red phosphorus. This reaction is called HVZ reaction. Here in this session, we have discussed only a few organic 9 reactions. Few more 9 reactions are there to be discussed. We shall discuss them in the next video. Okay. Thank you.